Welcome to this 360-degree scene captured by Perseverance rover on Sol 1538. At first glance, Mars looks simple: dusty ground, scattered rocks, and a silent horizon. But when we look closer, every detail reveals a deeper story. Start with the soil beneath the rover. It appears dry and lifeless, but its fine grains suggest ancient movement, perhaps once carried by flowing water or shifting winds. Some areas look compacted, as if they settled slowly over time, while others appear loose and freshly disturbed. These contrasts help scientists understand how the Martian surface changes even today. Now examine the rocks nearby. Notice their shapes: sharp edges, angular forms, and fragmented patterns. These aren't the smooth, rounded stones we find along rivers on Earth. Instead, they look broken, fractured, and weathered. This could be the result of freeze-thaw cycles, wind erosion, or violent geological events long ago. As you rotate the view, you'll see larger formations in the mid-distance: rock slabs with faint horizontal lines running across them. These are sedimentary layers. On Earth, layers like these are formed when water deposits minerals over long periods of time. Their presence here is one of the strongest clues that Mars once had a stable environment capable of supporting lakes, rivers, or even entire bodies of water. Look closely: some rocks display holes, ridges, or unusual textures. They may have formed from volcanic gas bubbles, chemical reactions with liquid water, or interaction with minerals rich in iron and sulfur. On Earth, similar textures are sometimes linked to microbial activity. We can't say that's true here, but Perseverance is gathering samples in case microscopic signatures of life remain locked inside. Shift your view toward the horizon. The distant ridges and plateaus reveal another process: erosion by wind. For millions of years, Martian dust storms, though thin, have acted like natural abrasives. They carve and sculpt the stones slowly, creating sharp silhouettes and smooth surfaces depending on orientation. Even the color palette of this scene tells us something: rusty reds, muted browns, and pale grays. That red shade comes from oxidized iron, the same chemical process responsible for rust on Earth. It's a reminder that Mars once had conditions where iron interacted with the environment, possibly with water. As we take in the full panorama, one idea becomes clear. Mars is not just a frozen wasteland. It is a geological archive, a planet with chapters written in rock. Perseverance's job is to decode those chapters. To drill, to collect, to analyze, and ultimately to help us answer a profound question. Did Mars once host life? Sol 1538 doesn't give us the final answer. But it provides more evidence, more clues, and more reasons to continue exploring this silent world. Because somewhere beneath this dust, a story billions of years old is waiting to be understood.